Welcome to today's class, and today we'll be looking at top JUPEB Physics past questions. And the first question here says, question number 1AI says, define unit vector. Define unit vector. A unit vector is a vector that has the magnitude of 1. It has the magnitude of 1, and it indicates only the direction of the vector. So a unit vector, for example, if I have J, I will indicate it with a hat. So we use a hat for indicating unit vector. So if I want to indicate vector A as a unit vector, there will be a hat on top of it to indicate that this is what a unit vector. And it is what used to indicate the direction of a vector quantity, as it only shows the magnitude as 1. Question number 1AII says, state the work energy theorem. State the work energy theorem. Now, the work energy theorem simply says that what the net work done on a particle in all directions is equal to the change in kinetic energy of the particle. What does this mean? It means that work done, net work done, is equal to change in KE. This is the same thing as saying that my net work done is equal to half mv squared minus half mu squared. So this is the formula for calculating the work energy theorem. According to this theorem, it says that what the net work done is equal to the what change in kinetic energy of the particle. Number 1b, it says a certain satellite is in circular orbit about the Earth at an altitude of 550 kilometers. So we're given the altitude, which is the same thing as the height, as 550 kilometers, which is the same thing as saying I have 550,000 meters. So then it said, if the satellite makes a revolution every 110 minutes. So it means they are giving us the time it takes a satellite to make a revolution is what we call period. So it means that our period here is 110 minutes. So if you convert that to seconds, that will give me 110 times 60. It means that my period in this question, 110 times 60, will give me 6,600 seconds. So they went further to say, Roman figure 1, that we have to calculate the orbital speed. So we have to calculate the orbital speed v, we do not know. And we know that our orbital speed v is equals to 2 pi r over the period. So how do I find this? Since I already have my period, I know that pi is a constant. I have to find my what? Radius. So it means that my r here is equal to the radius of the Earth plus the altitude attained, which is the same thing as saying I have 6,400 kilometers. So that is, okay, in the question they gave it to us as 6.0. So this is 6.4 times 10 raised to the power 6 plus, and my height here, if I convert it to be in standard form, this will give me 5.5 times 10 raised to the power 5. So this is plus 5.5 times 10 raised to the power 5. So this will mean that I have 6.0, 6.4. So I have 5.5. So at the end of the day, this will give me 6.95 times 10 raised to the power 6 meters. So this is the radius of this particular circular orbit that we're going to be using for this calculation. So for us to find the orbital speed, we know that our orbital speed is equal to 2 pi r over the period, which means that my orbital speed v is equal to 2 pi times my radius here is 6.95 times 10 raised to power 6 divided by the period in the question is 6,600. So this will mean that I have 6.95 so this will give me 43668 divided by 6,600. So that will give me 6616.4 meter per second. This is approximately equal to 6616 meter per second if you want to put it in whole number. But that is not all. They went further to say that we should calculate the centripetal acceleration of this particular motion. So if we are to look for the centripetal acceleration, our centripetal acceleration, so our Roman figure 2 says we should find what? Centripetal acceleration. And we know that our centripetal acceleration here is supposed to give us v squared over r. So this is the same thing as saying I have 6616.4 divided by the radius that we calculated earlier was 6.95 times 10 raised to power 6. So this means that I have 6.95 so that will give me 9.5. Okay, this is squared. So if I square this, I have 6616.4 squared. Then I divide this by 6.95. That will give me 6.3 meter per second squared. So the centripetal acceleration here, okay, our acceleration here is going to give me rad per second squared. So at the end of the day, we have our centripetal acceleration and we've gotten also the orbital speed of this particular question. That takes us to the next question, which is question number 1C, which says, state without proof Bernoulli's equation for a tube flow with varying cross-sectional area. State each of the components and each of the parameters with the associated SI units. So what they're simply asking us to state here is Bernoulli's equation. And according to Bernoulli's equation, it said that the pressure plus 1 over 2 rho v squared plus rho gh is equals to constant, where my P here is pressure, rho is fluid density, V is velocity, G is acceleration due to gravity, H is height. Or you can say vertical distance. So this is what Bernoulli's equation is talking about. So moving on to the next question. That is question number 2A, which is, what is diffraction grafting? Diffraction grafting is an optical device made up of many closely spaced parallel lines that diffract light into, disperse light into its component wavelength by interference. What does this mean? It means that this particular optical device separates light into its component wavelength, and it has a formula that says that d sine theta is equals to n lambda, where d is your spacing, also called your grafting constant, grafting constant. So we have a grafting constant is also called d. So we have our theta here is the angle of diffraction, angle of diffraction. We have lambda as the wavelength, and n is our order of diffraction. Order of diffraction. So this is the formula for diffraction grafting. So the next question says differentiate or distinguish between the following: coherent source and incoherent sources. Coherent sources and incoherent sources. Now for coherent sources, you have the frequency is constant. The frequency does not change. But for incoherent sources, the frequency may change. So that is one of the differences between your coherent source and incoherent sources. So moving on to the next question, that we should differentiate between constructive interference and destructive interference. Now for constructive interference, we discover that if I have my interference this way, this is constructive interference. Then this is destructive interference. So for constructive interference, you realize that the amplitude adds up. So our amplitude adds up. Amplitude adds up. Because they're moving in the same direction. But for destructive interference, your amplitude cancel out, because when I'm having a crest here, I'll be having a trough. So they are going to cancel out. So your amplitude cancel out for destructive, but they add up for constructive interference. And for destructive interference, when there is a crest, for destructive interference, you'll be having a trough. Unlike when you have for constructive interference, they both have crests at the same time or at the same point, and their crest, their trough are also at the same point. That takes us to the next question, which is question number 2C. It says, determine the angular position of the first and second order maxima of the light wave of wavelength. So we have the wavelength given as 400 nanometers, and we have wavelength 2 as 700 nanometers. Then it said incidented on a grafting containing, so our grafting, our grating was given as 10,000 lines per centimeters, which is the same thing as saying that I have 10,000 times 100 lines per meter, which is the same thing as saying I have 1 million lines per meter. You can write that to become that I have 1 times 10 raised to power 6 lines per meters. So we are asked to find the angular positions. So the first we are going to do is to find our D, and our D here is supposed to give us 1 over our grating, which is 1 times 10 raised to power 6. So it means that my D therefore is equals to 1 times 10 raised to power minus 6. But we know that our formula is D sine theta is equal to n lambda. This is the same thing as saying that it means that my angle is equals to, if I make angular position here to be the sort of the formula. This is similar saying I have my angle to be equals to sine inverse of n lambda over d. So it means I'll be calculating for each one of these. So let me create a table where I have my so in the question they say we should do it for the first and second order. For the first and the second order. So our order, so we have order on the table, we have the frequency, and then we have the angle. So if we calculate using this formula, for the first order, when my order was 1, for my first frequency there was 400. So if I calculate using this formula here, what I'll be having is sine inverse of, this is 1 times the frequency there is 400 divided by my d is 1 times 10 raised to power minus 6. So that will give me 400 exponential minus 9 so times 10 raised to power minus 9, because in the question what we have here is nano. So this is the same as saying 400 times 10 raised to power minus 9 meters. This is 700 times 10 raised to power minus 9 meters. So if we do this at the end of the day, for the first one, what we'll be having is sine inverse of 0.4. Sine inverse of 0.4. So our sine inverse of 0.4 is going to give us 23.6 degrees. So we are also going to do it on that same first order. We are going to do it for our 700 nanometers. So if we do it for our 700 nanometer, you realize that this calculation will give us a different value, because here, since we know that what we have is our theta is equals to sine inverse of n lambda over d. So this is the same as saying that I have sine inverse of 1 times 700 times 10 raised to power minus 9 divided by my d, which is 1 times 10 raised to power minus 6. So this will give me 700 so that will give me sine inverse of 0.7. So and that will give me 44.4 degrees. So I'll also do it for the second order. So I'll repeat this for the second order, 400 nanometers. So for the second order here, what I'll be having will be different here. So for the second order here, what I'll be having will become 2 times 400 times 10 raised to power minus 9 divided by 1.0 times 10 raised to power minus 6. So that will give me sine inverse of 0.8. So my sine inverse of 0.8 will give me 53.1 degrees. So I also do the same thing for that same second order. I would repeat the second order for the second frequency, which is 700, which means that my theta here would be equals to sine inverse of 2 times 700 times 10 raised to power minus 9 divided by 1 times 10 raised to power minus 6. So that will give me So that will give me sine inverse of 1.4. And if you are to look for the sine inverse of 1.4, it is not possible. So not possible. So it means that the angular positions of these angular positions for the first and second order maxima for the light wave of 400 nanometer and 700 nanometers are going to give me 23.6 degrees, 44.4 degrees, and 53.1 degrees. So that is the answer to the question of number 2C. Moving on to the next question, question number 3A. Remember figure 1 says, list 4 characteristics of wave. Now, some of the characteristics of wave include the frequency of the wave. We have the frequency of the wave. We have the amplitude of the wave. We have the velocity of the wave. We have the wavelength of the wave. We also have other characteristics of the wave. Now, these 4 characteristics of the wave, the frequency of the wave is measured in hertz. This is measured in hertz. Amplitude of the wave is measured in meters. Velocity of the wave is measured in meter per second. The wavelength of the wave is also measured in meters. The question said list, so there is no need for explaining what each one of these characteristics of the wave talks about. The next question, Roman figure 2 says, define linear magnification. Linear magnification is simply the ratio of the height of an object to the height of the image to the height of an object. What does this mean? What I'm saying is magnification or linear magnification is simply equals to height of the image over the height of the object. This can also be expressed in terms of distance to mean that I have what? The distance moved by the object or by the image over the distance moved by the object. This is what we call what? Linear magnification. The next question, which is question number 3A, which is Roman figure 3. It says, write down without proof the lens maker's formula for thin lens in air. Now, the lens maker's formula says that I have what? 1 over my focal length is equals to my refractive index n minus 1 in bracket 1 over R1 minus 1 over R2, where my F is focal length, N here is refractive index, and R1 and R2 are radii of curvature. So this formula here is my formula for the lens maker. So that's the lens maker formula. Moving on to the next question. So moving on to the next question, question number 4A. Roman figure 1 says, state Fleming's left-hand rule. Now, Fleming's left-hand rule is based on the magnetic field, and it said that if the thumb, the first finger, and the second finger are at right angles to each other, just as I have in my hand here, he said that the thumb will be pointing in the direction of force, while the first finger will be pointing in the direction of the magnetic field, and the second finger will be pointing in the direction of electric current. That is what Fleming's left-hand rule. So the second question says, state 2 factors upon which the magnitude of the force on a charge moving in the magnetic field depends on. Now, the charge on a magnetic field, the force of a charge in the magnetic field depends on, first, the speed of the charge. It also depends on the magnitude of the charge and then the strength of the magnetic field. So, number 4B says, an electron is accelerated by a 5.2 kilovolt potential difference. So, we are giving the potential difference V as 5.2 kilovolts, which is same as saying 5,200 volts. They say how strong a magnetic field, so we're looking for what? The strength of the magnetic field we do not know, must be experienced by the electron if its path is a circle of radius 4 centimeters. So they gave us the radius of the circle as 4 centimeters, which is same as say 0.04 meters. So we are looking for what? The strength of this particular magnetic field. And they are talking about what? Electron. So we have to talk about what? The mass of the electron. So mass of electron is a constant, which is 9.109 times 10 raised to power minus 31 kilogram. And we also have to talk about the charge of the electron. The charge of the electron is supposed to give us 1.602 times 10 raised to power minus 19 coulomb. So both the mass of the electron and the charge of the electron are constant. So the first thing we are going to do is to tell them that my kinetic energy is equal to EV, and this is also equals to half mv squared. So the V here is potential difference, but the small letter v here is talking about your velocity. So if I equate the two of them together, this is the same thing as saying that my EV is equal to half mv squared, which will mean that I have 2 EV is equals to mv squared. If I divide both sides by m divided by m, this means that my V is equals to square root of 2 EV over m. So this is the formula we're going to use to calculate the velocity of this particular charge. So this means that my velocity is equal to square root of 2 times the charge of the electron in this case is 1.602 times 10 raised to power minus 19. This is times the potential difference in the question is 5,200 divided by the mass of the electron in this case is 9.109 times 10 raised to power minus 31. So if I calculate this, this will give me 2 times 1.602 minus 19 times 5200. So this will give me 1.667 times 10 raised to power minus 15 divided by 9.109 times 10 raised to power minus 31. So that will give me square root of 1.83 times 10 raised to power 15 and that will give me that the velocity is equal to 427,664,75. So which is the same as saying I have 1, 2, 3, 4, 5, 6, 7. 4.27 times 28 times 10 raised to power times 10 raised to power 7 meter per second. So that's saying that my force is equal to EVB, and I also know that my force is also equal to mv squared over r. So this means that my EVB is equals to mv squared over r. So if I try to make B the solvent of the formula here, if I make B the solvent of the formula, what I'll be having is going to look like this. So if I make B the solvent of the formula here, I'll be having that my B is equal to mv squared over EVR. If this V cancel out one V, it means that my B will be equals to NV over ER. So with this, I'm going to calculate what my magnetic field strength will be. So my magnetic field strength will be equal to the mass of the electron is 9.109 times 10 raised to power minus 31 times the velocity that we calculated was 4.28 times 10 raised to power 7 divided by the charge of an electron is 1.602 times 10 raised to power minus 19 times the radius in the question was 0.04. So if I calculate this, this is 9.109 So I'll calculate this together. This is times 4.28 So I'll have B to be equal to 3.90 times 10 raised to power minus 23 divided by, now calculate this, 1.602 So this will give me 6.408 times 10 raised to power minus 21. So if I have 3.9 raised to power minus 23 divided by 6.408 raised to power minus 21. That will give me that my B is equal to 6.086 times 10 raised to power minus 3. At the end of the day, I'm going to be getting my magnetic field strength to be equal to 6.08 times 10 raised to power minus 3 Tesla, which is approximately saying that I have 0.006 Tesla. So that is the strength of this particular magnetic field. So that takes us to the next question. That takes us to question number 4C. It says, a step-up transformer primary coil has 400 turns. So the NP, that numbers of turns in the primary coil, is 400. Then it has the NS as 1200. So the primary coil is connected to an AC generator having an EMF. So the voltage of the primary coil is 150 volts. The first part of the question says we calculate the voltage in the secondary circuit. So if I were to calculate the voltage in the secondary circuit, we know that our NS over NP is equal to Vs over Vp. So we use this formula to calculate the voltage in the secondary circuit. And how do we do that? This is the same as saying I have 400. This is 1200 over 400 is equal to Vs over 150. So these two zero will cancel out this to 0. And 4 here, 1. 4 here will give me 3. So I'll have, so if I cross multiply, it means that my Vs is equal to 3 times 150. And that will give me 450 volts. So Roman figure 2 says, we should find the current in the primary circuit if the current in the secondary circuit is, so they are giving us the current in the secondary circuit as 5 volts, and we have to find what IP. We do not know, but we know that for an ideal transformer, so if the transformer is ideal, it means that my VI for the current, so for the secondary, will be equals to my VI or IV. Let's do it IV. The ISVS will be equals to IPVP. So this means that the power generated in the secondary part of this transformer must be equal to the power generated in the primary part of this transformer, which means that what I have here is 5 times my Vs was 450 is equal to the current in the primary is unknown times the potential difference or voltage in the primary is 150. So I'll divide both sides by 150 divided by 150. So this means that I have my IP to be equals to 5 times 3, which will mean that my IP is 15 ampere. So the third part of the question said we should calculate the power drawn by the primary coil, primary circuit. So Roman figure 3, the power in the primary circuit. The power in primary circuit, power in primary is IP VP, because power is equal to IV. So what I'll be having is IP VP, and that will give me 15 ampere times my VP in the question was given as 150, and that will give me 15 times 150. That will give me 2250 watts. So, and then Roman figure 4 said we should calculate the power supplied by the secondary circuit. And power supplied by the secondary circuit is ISVS. And that will give me, so the power in the secondary circuit, ISVS, will be equal to, so my IS is 5 times, my VS is 450. So I have 5 times 450. And that will give me 2250 watts. So we've come to the end of today's class. Thank you for staying with us to this time, and stay tuned for more questions and tutorials on our channel.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao, NEET, IALT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.